Hey everybody. On Friday in class we got some practice solving multi-step equations using combining like terms, the distributive property, having to deal with some fractions. Tonight we're going to go over some examples that'll show you how we can apply multi-step equations to answering real-world type problems. Our first example here, we're looking at bird migration. It says a flock of cranes migrates from Canada to Texas. The cranes take 14 days, that's 336 hours, to travel 2,500 miles. The cranes fly at an average speed of 25 miles per hour. How many hours of migration are the cranes not flying? Let's figure that out. Let's underline our question, and I'm going to need a variable for that. Let's go h for hours. And we can say h represents hours not flying. Just excellent handwriting. Unbelievable. Now we want to make sure we get our important information. They take 336 hours total, and they travel 2,500 miles. And we know the speed they fly too. We know they travel 25 miles per hour. So we know the total distance they travel is 2,500. And that's going to be equal to the speed they travel times the time they spend flying. Now, we know that it takes them 14 days to travel that far, but birds can't fly for 14 straight days, right? We're looking for how much time they're not flying. That's what h represents. If we know there's 336 total hours that the trip takes, we subtract the time that they're not flying. This right here gives us the time that they actually spend flying from Canada to Texas. So now that we have our equation, we can start solving it. So this looks like some of the problems we looked at yesterday. A couple different ways I could solve this. I could distribute 25 into these parentheses. That's one option. Or I could get rid of this 25 right now by dividing it on both sides. And actually, I think that's what I'm going to do, because I see I have 2,500. I know 25 is going to go into that. 2,500 divided by 25 is just going to give me 100. And that gives me 1. So now I just have what was in the parentheses, 336 minus h. My next step, I'm going to get rid of this constant term. It's positive 336, so I'm going to subtract it. Right? We get negative h equals, that's going to give me negative 236. And now we got another one of those situations. I got this negative h. Remember, we can just say that there's a 1 right there. We can say this is negative 1 times h, because that equals negative h. So we'll divide by that negative 1, and we'll get h equals positive 236. So they are not flying for 236 hours. Now, you could have done this the other way. You could have distributed this 25, and you could have gone through the reverse order of operations. You could have gotten your answer. We would have gotten the exact same thing as long as we did all of our steps right. If you don't believe me, feel free to try it out. All right, let's check out another example. Each school day, Sam buys 2 sandwiches and a chocolate milk, which costs $1.50. On Friday this week, Sam also bought a bag of chips for $1. If you spent a total of $41 this week, how much does each sandwich cost? Let's underline that last part. How much does each sandwich cost? We know that each school day, Sam buys 2 sandwiches and a chocolate milk. That's important because we're talking about for the entire week. So we got to know how much he's getting each day. Oh, and we know the milk costs $1.50. Should include that in here too. Milk costs $1.50. And then on Friday, So just on one day, he also bought a bag of chips for $1. And we know that the total is 41, so that's important. All right, let's define our variable. We want to know how much each sandwich costs. I'm going to use C for cost. I don't like using S as my variables because all my S's look like 5s. So C is going to be my cost of one sandwich. Put that, sandwich. Okay, so I can write our equation now. I know 41 is the total. That's going to equal, now on all 5 days, he gets 2 sandwiches, which cost C dollars each, and he gets 1 chocolate milk, and we know that that costs $1.50. So this expression inside parentheses here, this is his cost for each day, and we have to multiply that times 5. And then we know on Friday, he spent $1 extra. So a couple different ways we could go about solving this here. This time, why don't we use our distributive property? We can distribute this 5. We can distribute it to there as well. Now, if you want to try it a different way, feel free, and you can see if you get the same answer as us. 5 times 2c is 10c. 5 times 1.5, well, I know 5 times 15 is 75, so that must be 7.50 plus 1. My parentheses are gone after I distributed. I can combine like terms here, and that's going to give me 41 equals, these guys can go together, 10c plus 850. And now I just got a two-step equation. Let's subtract. I have 10c equals 41 minus 8 is 33. $33. If we take away 50 cents, we'll have 32.5. And now I divide by 10. And I get C equals, when you divide by 10, we just move the decimal to the left one place, 3.25. So each sandwich costs $3.25. All right, we have one last example here. This one's a shorter problem. It's not even really a word problem or a real-life situation. But consecutive integer problems love to pop up on standardized tests like the ACT or the SAT, so it's good to be prepared for them for when they do show up. This problem says that 3 consecutive odd integers add up to 75. What are they? We could probably do some trial and error, some guess and check to solve this problem, but we could also write an equation. We can always represent an odd integer as 2n plus 1. No matter what n is, as long as n is an integer, 2n plus 1 will always be an odd number. If n is 0, 2 times 0 plus 1 is 1. If n is 1, the answer is 3. If n is 2, it's 5, and so on. So we know odd numbers count it by 2's, 1, 3, 5, 7. So our next odd integer would be 2n plus 3. And our third odd integer would be 2n plus 5. And now we can write our equation, because we have our odd integers. We've got 2n plus 1 plus 2n plus 3 plus 2n plus 5 equals 75. Now I can combine like terms, combine my variable terms, where the n's are, we get 6n. We have our constant terms, 1 plus 3 plus 5. That gives me 9 equals 75. We can solve this equation now. Subtract 9. 6n equals 66. So we divide by 6, and n equals 11. But remember, we weren't just looking for n. We need that, and what we can do is we can plug that into our equations up here. So we get 2n plus 1. If n is 11, 2 times 11 is 22, plus 1 is 23. 2 times 11 is 22, plus 3 is 25. 22 plus 5 is 27. These are the three odd integers we were looking for. So that's it for tonight's lesson. Finish up your notes, don't forget to submit them, and I will see you guys in class on Monday. Have a good night. Bye.